All right, and before we get started, Sophie and I just want to thank our first session speakers again for the lovely lightning round talks that we had in Q&A session to end it off. Excuse me, folks. Do you mind? Thank you. So our next presentations are going to be from some of our government sponsors of this event. And our first speaker is going to be Dr. Roman Makarevich, who is the program director at the National Science Foundation, NSF, and he received his PhD in 2002 from the University of Saskatchewan in physics. He was a professor at the University of Alaska Fairbanks for 8 years until joining the NSF in 2021. And he's going to be talking to us about the NSF grant proposals and ways that students can get involved with that. So without further ado, please welcome to the stage Dr. Roman Makarevich.
Thank you, Andrew. So this presentation was supposed to be given by my colleague, Dr. Shikara, but unfortunately she got injured and she couldn't be here today. So I'm going to give that presentation on her behalf and also on the behalf of all of us in Geospace part of NSF. So this is an outline of this presentation. I'm going to bombard you with lots of information, not all of which is directly relevant to you right now, but as you progress through the system, more and more of that will become directly relevant. So I'll start with the structure of NSF, what it does, and I'm going to drill down all the way to what we call the program level. Aeronomy program is the most directly relevant program for our research here. Then I'm going to talk a little bit about how to, well, use our website, how to find information, and I'm going to talk about proposal preparation and how NSF proposals are evaluated. Then I'm going to focus more on opportunities available to you, but also to all members of Geospace community. And then I'm going to finish with some concluding remarks. So as you can see here, NSF mission, and that's the part that does not really change, is threefold. It's to promote the progress of science, secure the national defense, and advance national health, prosperity, and welfare. And one can easily argue that space physics is directly relevant to two of these, and the third part is more to do with what we call broader impacts. So I'm going to talk about that in detail later in this talk. The next part, which we call priorities, it does change. It does change every now and then, every few years or so. And the current three major priorities are given on this slide. So we have here strengthening established NSF. That's what NSF does. That's what our bread and butter business is. We support research. And then the second one is something that the current director is very keen on advancing, this idea of finding and inspiring the missing millions, basically to broaden participation in STEM research. And then the third part is, again, something that is very close to the current director, is this idea of transfer of knowledge and technology partnerships, innovations. So I'll be talking about different parts of NSF, including the newest directorate called TIP, which is a Technology, Innovation, and Partnership Directorate. So let's talk about different parts of NSF. There are currently 8 directorates, and we are in GEO, which is a directorate for geosciences. And geosciences supports, of course, research in the fields covering domains like Earth, ocean, and atmosphere. And you'll notice in the next slide that directly translates to divisions. So going one level down from directorate to divisions, we have Earth Sciences, Ocean Sciences, and our division, my division, Atmospheric and Geospace Sciences. So you'll notice also there is a part of Geo called Polar Program. This is not a division, it's called Office of Polar Programs, and the reason is mostly historical, but now it's basically part of Geo. And then we have the newest division in Geo called RISE, which is Research, Innovation, Synergies, and Education, specifically for geosciences rather than, it's somewhat similar to TIP, but at the directorate level rather than in the CEF-wide level. And coming one level down, AGS is a division of Atmospheric and Geospace Sciences, and within AGS we have 3 clusters now. So this is our new structure. The 3 classes are Atmosphere cluster, Geospace cluster now. It used to be Geospace section, now Geospace cluster, and Infrastructure cluster. So I'm going to talk about now Geospace cluster. So you can see the lowest level of structure at NSF is programs. And usually we have a program officer that manages particular program, and we have here Shikarazada, who is the program officer for aeronomy and CEDAR. Then we have Mangala Sharma, program officer for space weather, and she also currently serves as Geospace cluster coordinator. Lisa Winter is responsible for solar terrestrial. She's currently on detail to NASA. Chelin Huan is a program officer for magnetospheric physics. Tain Huan is a program officer responsible for data infrastructure, not just in aeronomy, but across Geospace, and also actually across AGS too. And then myself, you can see some text, which is somewhat confusing, but that's okay. So I used to be part of Geospace section in my program of Geospace facilities. Now there is an arrow pointing to infrastructure cluster. What it means that the program and myself as a cognizant program officer has been moved from Geospace section, which is now Geospace cluster, to infrastructure cluster. But for all intents and purposes, I remain deeply involved with the work done in Geospace cluster. So we also have a new structure of the division. Rather than section heads, we have what we call D, which is Deputy Division Director, and we have Division Director Anna Johansson is our current Division Director, and David Virardo is acting Deputy Division Director. So these are the faces that you'll see pretty much every year at these meetings. We have some people leaving, some people onboarding, but the core will remain largely the same. So just a quick reminder what our aeronomy program supports. As you can see, it supports research in domains of mesosphere, thermosphere, and ionosphere. It also supports coupling, so coupling processes from the stratosphere to this MIT system, including magnetosphere. And it also supports research in plasma physics of these magnetosphere-ionosphere interactions, including ionospheric heating experiments. Oh, one important thing here is that this program, unlike CEDAR, of which CEDAR is a part, accepts proposals all year round. So there's no deadline, there's not even target date for aeronomy proposals. For CEDAR proposals, there is a target date. I'm going to talk about it in a few seconds. How do you find information from NSF? Well, of course, you can talk to us, program officers, but in your spare time, you can browse the website. If you click on a link or menu called focus areas. You'll see all the different focus areas, current focus areas at NSF. And if you scroll down at the bottom of the page, you can click on search all opportunities, find funding, and apply. This is if you're interested in all sorts of opportunities, not just those that we tend to highlight at these meetings. And at the very bottom, you'll find also a link and information that is perhaps somewhat overlooked, and that is current funded projects. So you can click on this, or you can simply Google NSF aeronomy and scroll down and click on the link saying the current awards, and you'll see the list of the current awards, which will be actually quite insightful in terms of which projects with their titles, which PIs, which universities are currently funded, and also, importantly, the budgets, I mean, the total funded to date to these projects. So there are two important sources of information in terms of how to prepare your proposals and how to write your proposals. The first one is called PAPPG, which stands for Proposal and Award Policies and Procedures Guide. So it's a fairly long document, but you can, of course, search. It can be downloaded as PDF, or you can look at it as a web page. I'll show you in a second how it looks like. It basically provides everything you need to know about how to prepare your proposals. It contains information about eligibility, which institution can or cannot submit, which costs are allowable, what can you budget for and how, and also how to actually prepare, how to format your proposal. It describes the process and how, well, basically it describes the process of how your proposals will be evaluated and also the criteria. And again, I'm going to talk about these two merit review criteria in a second. And importantly, this is also the part that is somewhat overlooked. It outlines reasons for why proposals may be returned without review, whether it's formatting issues or not having the required sections, things like that. The second important document that you should consult before even started working on your proposals is what we call program solicitation. CEDAR is one program solicitation, but of course there are others. So this is how the program solicitation looks like for the current CEDAR solicitation. It has information about deadline or target date in case of CEDAR. It has basically a description of what the program supports. It has a list of various contact people, program directors, who you would ask questions in case something is unclear after you read the proposal, after you read the solicitation. Again, information about eligibility, various budget limitations. Does that solicitation require pre-proposal or letter of intent? CEDAR does not, but many other solicitations do. And also, at the very bottom, you'll find information about how much NSF is proposing to spend on that particular program solicitation at any given year. And therefore, well, they also have information about what the expected size of the award is, and therefore, how many awards NSF is expecting to make. So the same information is available from the web page for that solicitation. Again, solicitation can be downloaded as PDF, which can be searched, or you can just look at this web page. So again, various highlighted parts here show due dates, whether it's a deadline or target date, synopsis for the program, what it supports. But at the very bottom, you'll see browse projects funded by this program. Again, this is a very important piece of information, piece of the puzzle that is somewhat underutilized. So here's a list of all the current active solicitations. We have here CEDAR with the target date of 1st of Friday in May. This is the most relevant program and solicitation for this audience. Then we have the sibling solicitation in the GEM community, in the SHINE community, with the target dates of September 30th and October 7th, respectively. And then something that has been around for a while. We call it faculty development in geospace sciences. Now it used to be just space sciences, FDSS. So I'm going to talk about this program in a second again, but it's a biennial program now, unlike before. And the next deadline for that program is March 3rd, 2025. And the CEF also supports what can be called career trajectory proposals. So starting from the graduate level, we have graduate research fellowships, postdoctoral fellowships at the postdoctoral level, career awards for assistant professors, for early career faculty, and then all the way down, min-career advancement awards. So let's talk about this in detail. As an undergrad student, I'm not sure how many in this audience are undergrads, but as an undergrad student, you don't necessarily directly apply for any opportunities. Instead, it's an institution that applies to host what we call REU programs. It stands for Research Experience for Undergraduates. And so on the right, you'll see a picture for one of these projects. It's from Boulder Solar Alliance Research Experience for Undergraduates. So students apply individually to institutions that act as hosts for these programs. Then for graduate students, we have a very prestigious but also very competitive program called GRFP. At the bottom, you'll see it stands for Graduate Research Fellowship Program. Again, it's very competitive, but even if you're not successful, I still think it's a very good opportunity to develop your skills in writing proposals. So proposals that you'll be submitting to this program would not be very large. It will be something of the order of 2 pages of the proposal itself, the narrative, and then I think it's 3 pages of a personal statement. But it gives you a very good opportunity to get a sense of what it takes to really develop an idea into a proposal. So after graduation, usually it comes a postdoctoral fellowship. And AGS, our division of atmospheric and geospace sciences, has its own what we call postdoctoral research fellowship program. So this is a program that is specific for our division for atmospheric and geospace sciences. If you were to apply and were to be selected, it would fund you directly. So the way to then think about it is you would choose your host institution. So it doesn't have to be an institution from which you graduated. It can be any US institution, which is kind of nice. You'll probably still talk to that institution before you apply to select a mentor and select a group, but you would be funded by NSF as an individual, which is somewhat unusual and pretty cool. Again, there's no deadline for this program. You can apply at any time, but you would have to be within 2 years of graduation. And on the right, you'll see some of the photos and some of the names for recent PRFs in Geospace that we funded over recent few years. It is just a general advice. If you're unsure about anything I have told you today, or after you perhaps browse through our website or any materials I mentioned, if you're still unsure, just ask us a question. You don't have to write a one-pager. If you have an idea of proposal, we might ask you to do that, and send us to help you identify the program that would be most suitable to you. OK, so let's talk about the proposals themselves. Again, that would differ for things like RU or PRF applications, but this is a general structure of all NSF proposals at a certain level. So we have a cover page, which is shown here on the right. We have a project summary, a very important part of any proposal. That's where you would highlight everything that you want to say, basically, about your research. What's important? What do you want to investigate? What would be the intellectual merit? What would be the broader impacts? And then the heart of the proposal would be this part called project description. It's typically 15 pages or less. And that's where you basically present all your ideas about the project that you want to pursue. Then the rest of it is fairly technical. Current and pending support is usually prepared by your Office of Sponsored Programs. The same with budget. You would probably need to provide your input in terms of budget justification and things like that. But again, you would be helped a lot by your Office of Sponsored Programs. So next part is how NSF evaluates proposals. We have two merit review criteria, which are called intellectual merit and broader impacts. Intellectual merit is basically what is the potential of this activity to advance knowledge, and broader impacts is potential to benefit society at large. Both review criteria must be addressed, and both criteria are very important in evaluating this project. So again, these two merit criteria, intellectual merit, the potential to advance knowledge, and broader impact, potential to benefit society. And our reviewers are asked these questions for both merit criteria. Okay, so is this work original, potentially transformative? That's the first question we ask. Is the work plan reasonable? Is the team qualified to pursue this research? And do they have resources necessary? Does the institution provide these resources? Broader impacts are somewhat, perhaps, more difficult to express what you want to do in terms of broader impacts. But there are useful documents to help you to tackle that. There are different areas that you can address, and they're basically listed here, and there is much more available from NSF. So broader impacts include things like, well, how you plan to train the next generation of researchers. How do you plan to broaden participation of represented minorities in STEM? Do you plan on strengthening any partnerships, international, on local level? How do you plan on disseminating results of your research? If you want to say, well, I'm going to publish in JIRA, that's not probably good enough. We are talking about broad dissemination to public outreach. So do you plan to enhance infrastructure available to the community? And then all that, it can be quite intimidating, but this is a very good advice. It's better to focus on a few things that you know well and can contribute significantly rather than do all of them at once without contributing much to any of them. So I already mentioned this very important source of information called PubPG. If you're unsure about anything, you just go there, you search. If you're still unsure, feel free to ask us. And something that, of course, this source of information wouldn't tell you is how exactly proposals are evaluated. We have talked about it, but nothing really substitutes hands-on experience. So if you are close to graduation, you can contact us immediately after you receive your PhD. You can volunteer to be what we call ad hoc, mail-in reviewer. So we'll send you a proposal, you evaluate it, you'll evaluate both merit criteria, intellectual merit, broad impacts, or whatever additional solicitation-specific criteria we may add. And you'll submit it, and that's how you learn, right? The next level from these ad hoc reviews would be to volunteer to be a panelist. In that case, you would be given several proposals, and you would discuss these proposals as a panel, as a group, with a program officer leading this activity. So that's, many people say that's a very useful thing for them to experience in terms of how to, well, write proposals and how to evaluate them and how other people tend to evaluate them. A couple of things that, again, are somewhat overlooked. And one of these things is a work plan. So on the left, you'll see an example of a work plan that is somewhat weak. So let me just read through it. PIs Howe and Fogarty will go into the field with the graduate and undergraduate students in year 1 to collect samples, and will complete the proposed analysis by year 2. So that's a not particularly good example of, well, of a work plan. Instead, what we recommend for you to do is to be much more specific than that. Okay, so draw out a timeline, not year 1, not just year 1, year 2, year 3, whatever, but specific timelines with specific tasks to be completed by a certain time. Explain how each analysis contributes to your hypothesis. Clarify a role of each PI and each graduate student. And there are tools for you now to help you in that. I'll be talking about it later on. And most importantly, show that you can actually do that. You can complete it within the necessary, within your proposed timeline. The same thing about the budget. So the most important thing about the budget, it has to be realistic and it has to be defensible, right? So it has to be consistent with the scope of work that you're proposing. That's the most important aspect of a good budget. With the budget also comes budget justification. That's how you, well, prove that you need that much money to complete that activity, that research project. Another part of the proposal that is somewhat overlooked is data management plan. Some of the common weaknesses are listed here at the bottom. An example of a weak data management plan would be statements like data available upon request from PI, or data will be available at the time of publication, or data will be published using private storage. These are all not particularly good examples of how to write your data management plan. So on this slide, Shika has listed some of the best practices that she encountered. The first item on this list is actually applicable to anything we do here, right? All the maps, figures, legends have to be readable, otherwise what's the point? Then the second best practice is to, well, again, it's about a clear work plan. So make sure that your timeline is specific, make sure that you outline a role for each specific participant in your project. Again, the budget has to be well justified, and if you treat broader impacts the same way you treat intellectual merit, that's always a good thing. So if you want salary for you to do research, that's of course what you include. If you need support, financial support for your broader impact activities, that always looks good on a proposal. And the final piece of advice here is that, well, yes, you would be responsible for your proposal as a principal investigator, but it's always a good idea to give that draft to someone else to read in addition to your sponsored research office. And some of the common proposal mistakes are listed here on the right. Again, your proposal, it doesn't look good when your proposal is too incremental. Yes, you have to base your proposal on the previous work, but it has to advance significantly compared to what you have done before. Proposal can also be too ambitious, or on the contrary, it could be not ambitious enough. And then make sure that the proposed activities and the proposal plan actually addresses the stated science goals. So that's pretty much my last slide. Again, I have talked about probably the most important part of this presentation. If you are close to graduation, think about volunteering, write to your program officer, volunteer to be an ad hoc reviewer on a panelist. Thank you.
We ran out of time for questions, but thank you so much for that talk. Thank you again. Our next talk will be given by Dr. Caitlin Greer. Caitlin Greer received her PhD in 2013 from the University of Colorado. Her dissertation was on the fluid dynamics of the upper stratosphere, lower mesosphere disturbances, and was advised by Dr. Geoffrey Thayer. She's a researcher at LASP and works on both hardware missions as well as science grants. She's on the Decadal Survey's ionosphere-thermosphere mesosphere panel. And finally, she's a former CEDAR student representative and a current member of the CSSC. Please welcome Dr. Caitlin Greer.
All right. So you guys may have seen on the agenda, abbreviated in different places, GC. Well, what is a GC and how can you get involved? Let's see if I can. There we go. OK. So GC stands for Grand Challenge Workshop, and they're kind of a grassroots way that we organize part of the CEDAR conference. It addresses an urgent, overarching question which required a multi-year effort from within the CEDAR community. So this is going to be something a little different than the standard workshops you see. They're 3-year efforts, and they're usually convened by a diverse group of conveners. And they have specific goals and topics for each of the 3 years. So you don't see them doing the exact same thing each of the 3 years. So for example, the first year, the topic would be introduced to the CEDAR community in the plenary session, and then provide updates in the second and third, and then a summary after the third. So I just want to give a little shout out to the current grand challenges. In case you're interested. The one that's in its 3rd year, so they're doing updates and providing summaries, are interhemispheric asymmetries and their impact on the global ionosphere-thermosphere system. Year 2, so in the middle of their grand challenge, is the role of gravity waves in the mesosphere, thermosphere, and ionosphere cross-coupling and irregularities, observations and numerical simulations. And then the new one this year is impact of terrestrial weather on space weather of the ionosphere, thermosphere, mesosphere. The other thing that's really important to note that I put up here is the conveners, all right? Now, these conveners are also going to be listed on the workshop web pages that if you go into the agenda, you'll notice that each of the grand challenges are a link that takes you to a workshop page, and they'll have the list of the conveners. I'm going to say that this is important because you might want to contact these people. All right, so you may be asking, well, okay, how do these grand challenges get selected every year? So each year we have the opportunity to have a new grand challenge selected by the CSSC. So that's the committee that organizes the CEDAR workshop. We usually have 3 to 4 submissions, although that varies from year to year. And I will note that conveners on a grand challenge and the CSSC cannot vote, so the conflict of interest is there. So if you ever end up trying to convene a grand challenge, you might be a little strategic about how you pick conveners. I also put up here the current 2024 CSSC member list. I actually realize this is not a complete list. So if you want to know the complete list of the conveners or the CSSC members, you can go to the workshop webpage and they'll have them all listed. The other reason I'm highlighting who the CSSC members is, I helped put together the student scientist scavenger workshop or sheet, and one of the tasks for you as a student on that sheet is to find CSSC members. So what I really should have done is put all our photographs up here so it would be easier to find, but you'll have to look at all our badges to find us. All right, so how can you participate in a Grand Challenge this year? Well, attend the Grand Challenge workshops. So you gotta see the meeting agenda. Number one thing you can do is ask questions. And I know this can be a little intimidating if this is your first CEDAR workshop, but I think asking questions is really valuable for a number of reasons. The first reason is, honestly, if you have a question, other people in the audience probably have that question too. So don't be embarrassed to ask it. The second one is that speakers actually really enjoy getting questions. It means you're engaged, and they had some sort of, they were able to transmit some of their knowledge to you, and they really enjoy having that interaction. And the last one is I would say the vast majority of the people at CEDAR are very kind and understanding, and they want to hear from you. So please do ask questions. You can contact a convener through email. Again, those conveners are listed on the web pages. And you can also volunteer to take notes. This is really valuable to the conveners because we have to put together a report at the end of our workshop of what we did, how many people were there, what was discussed, that kind of thing. So that is also hugely valuable. Plus, it might help you take in some of the information too as you're trying to absorb what's going on. All right, so that's this year. What about next year? Well, you can actually get even more involved in a Grand Challenge next year. Before the workshop, contact the convener of a current Grand Challenge workshop and just volunteer to assist. The conveners of workshops are strongly encouraged to have student co-conveners and student participation in their workshops. It's a really big component of our CEDAR workshop, and our goal is to have you as students really strongly participate. So things you could be doing next year for a Grand Challenge. You could be planning the next workshop. So that might be, well, what do we want our focus topic to be for this year, for this workshop? Who do we want to invite to come speak? Who has some of the latest cutting edge research that we want to come and do that? You can say, oh, I just read a really great paper by Jones et al. I think they might be a really great speaker this year. Let's see if we can invite them. And then, you know what? You might get to interact with Jones or whoever that is, and that might be a new opportunity for you in the future. You can help run the session, which I know doesn't sound quite as exciting, but is a huge help to the conveners. This is everything from note-taking, running the virtual components. I know that I personally am a convener who really struggles with running the Zoom and everything and trying to run the actual workshop session at the same time. We need people to help us with timing, to keep everybody on schedule because nobody likes to miss lunch. You need to have someone help manage microphones running around and asking questions and answering. You can also participate by contacting the conveners and volunteer to give a relevant presentation. All right, now this also sounds pretty scary initially, but that's actually how most of CEDAR is done. You find out what workshops are being run that year, and you contact the convener and say, hey, I've done some really cool research in this area. I think the community might be interested for these reasons. Do you have a short time slot for me to talk about my work? It helps make a unique contribution to the session. And also, again, remember when I was talking about how much we love to have questions and discussion at these workshops? Be prepared for a lively discussion and at least a couple questions. And finally, now this is a big one, you could propose a grand challenge. Maybe you see an open need in the community, an open area of topic that just really needs a concentrated multi-year effort to really be addressed. You can propose a grand challenge. All right, so that leads into automatically, well, how do I propose this grand challenge? All right, so the first thing you need to do is recruit your team. Usually this is a diverse group of conveners from within the CEDAR community, or you can even reach outside the CEDAR community and bring in other experts, say from the GEM community, if there's some good crossover there. But you want a mix of different career stages, so students, early career scientists, senior scientists, specialists, related topic scientists. Most of these grand challenges have at least 4 conveners, if not more, up to like 10. And then what you'll do as a team is you'll develop a proposal. You'll need to articulate the challenge. What do we need to study or work as a community towards? What its significance is, and then how it fits with the decadal survey or strategic plan. Now, I don't know if you've heard of these documents yet. The strategic plan is the CEDAR strategic plan called A New Dimension. The document, I believe, is linked on the web page, or the CEDAR workshop webpage. Another guiding document for our community is the decadal survey. This is a survey that's, by its name implies, we do every 10 years. And we look at what progress has been made in the community, and where are we going next, what mission should we do, what science should we do. The latest decadal survey, we think, is gonna come out in early fall this year. I think there's gonna hopefully be an update tomorrow in the plenary session about that. So stay tuned for that. But the other thing I wanna say about the decadal survey, you should get familiar with it anyway, because most proposals that you will write have to have a section on how what your work is that you're proposing is relevant to the decadal survey. So this would be good practice for how to write those sections. And then the next thing you need to come up with is a timeline for your grand challenge with objectives for each year, including even maybe who might be your plenary speaker for each year. So there'll be a suggested tutorial speaker, and then topics or focused topics for your grand challenge workshop. And then you will submit everything. There's a digital form on the CEDAR workshop website, and there's a deadline. It's usually early spring. So that's how you propose a grand challenge. I commented that you probably are excited about lunch. So hopefully, if you have any other questions, I don't know that we have time, but you can, okay, we might have time if there's one.
I think we have time for one quick question if
Okay.
there's somebody in the audience.
Okay. Oh, there's a question. Okay.
Besides the relevance to the 2 documents, are there any other factors that you'll look at for the efficacy of a grand challenge proposal?
So one of the things that you'll need to keep in mind is what grand challenges have been proposed in the past. And so we like to rotate through topic areas. And so for example, if there was recently a gravity wave grand challenge, we don't want to turn around and do a gravity wave challenge the next year. What we're trying to do is engage the entire CEDAR community. And so that's one of the other areas that we focus on.
Is that on? That is on. All right, thank you so much again, Caitlin. Give another round of applause. Perfect. Well, I'll break now for our favorite time of the day, lunchtime. But before I do, I want to say I misspoke earlier. The movie night tonight will actually be in Porthole. It will not be in this room. You'll be very alone if you come to this room, because there will be nothing going on. But yeah, come back at 1:30, I believe. 1:30, we'll have our SciComm talk. So have a good lunch, everyone.